Hey guys, let us look at question 2 from November 2022, Physical Science Paper 2. Without any waste of time, let us get straight to our question. So question 2, it says, we are given a table here. It says A to F in the table, which is below, it represents what? 6 organic compounds. So we have A here, we have B, we do have C, we have D as well, E, and then what? And then F. These are our what? 6 organic compounds. Now, what do we need to do here? From 2.1, we are asked here that 2.1.1, you must write down the letters that represent 2 organic compounds that are isomers of each other. So we look at isomers now. It must have what? The same what? Same molecular formula. Same molecular formula, but what? But different what? But different what? Different structural formula. Structural. In fact, this is structural formula here. Structural formula. So we do have different what? Different structural formula. Okay, now which 2 compounds here that are isomers? Let us go look at this. Let us look at A and B. It can be correct because A has 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons there. Let us look at C and D. C and D, we have CH3, CH2, CH2, and then a carbon here, meaning I have 4 hydrocarbons this side. But here, let us look at this. CH3, CH2, C and CH3. So the number of carbons are equal here, but remember that C is an what? Is an aldehyde. It is an aldehyde. And then what about D is a what? It's a ketone. So these 2 here are what? Are isomers. And we can say they are functional isomers. So we go to 2.1.1. We can say letter C and what? And D are what? Are isomers. Let us move to the next question. 2.1.2, the type of isomers. We are given options here whether it's chain, functional, or positional. And I think I've just mentioned now that we have what here for 2.1.2? We have a functional isomer. It's a functional isomer because they have what? They have the same molecular formula, but different what? Different functional group. So it is functional isomer for 1 mark there. And therefore 2.1.3, we are tasked to do what? To write down the general formula of the homologous series to which compound B belongs. Let us go and check which one is compound B. Now with compound B, we can see that compound B has triple bonds. So triple bonds, it is an alkyne. If it is an alkyne, what is the formula required now, or the general formula? This is going to be CN, H2, N, and then minus 2. This is the general formula for what? For alkynes. So the first thing you must do here, you identify whether you have an alkane, alkene, or alkynes. It will be easier for you to do what? To write your general what? Formula. So this is the general formula of the alkynes. Let's move to 2.1.4. 2.1.4, we must write down the name of the functional group of compound F. So we need to go to compound F and see in compound F what do we have there. So compound F, this is compound F. Let us go to compound F. Now, compound F, we can see that it consists of an OH. Now, an OH is an alcohol, but they are looking for the what? For the functional group. What is the functional group of what? Of alcohols. This will become what there? The hydroxyl group. So our answer there will be the hydroxyl group. So we can come and say 2.1.4 Our answer, it is the hydroxyl group. The hydroxyl group. Because it is what? It is alcohol. So don't forget here, you were not asked about homologous series, but they ask you about what? About the functional group. It is the hydroxyl group. Let's go to 2.2. 2.2, write down the IUPAC name of compound A. We need to go back to compound A so we can see which compound we are talking about. Let us look at compound A. Now, compound A, I see it has a Br here, meaning this is a haloalkane. But now, how do we then name compound A? Now we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. So the longest chain there is what? Is 6. And we know that if it's 6, it's going to be hex. But now remember, number 4, we have a what? We have a Br. And then on number 3, we have a what? We have a methyl. But 2 of them, in chemistry, we say di. And therefore, how do we then name this organic compound? How do we then name this organic compound? So what we are going to do now, we can draw the organic compound. We have C. In fact, we have CH3. So we do have CH3 here. That's what we have. And therefore, we also have CH2, this side. And therefore, what else do we have here? We have, in fact, we can draw it like this so that we can all understand. We can draw it like this so that we can all understand our structural formula here. We can start by saying we have C, which is 3 carbons here. And therefore, we also have another carbon that has a side chain here. Okay, and therefore we also have another carbon that has 1 H or hydrogen and a what? And a Br. But now on this carbon now, we have a carbon that is joined with what? With CH3. So we have 1 here, we have 1 and another 1 this side. And therefore, we also have another carbon here that is joined. So we have 2 hydrogens, and therefore we also have the last carbon here with 3 hydrogens. Okay, so this is what we have here. We can use a different color there. How do we then count? This is number 1, this is number 2, this is number 3, number 4, and number 5. 6 is here. Now, which one was not counted here? We can come and say number 2 here. In fact, there is a mistake here. This is not number 2 because it is not connected. Our number 2 is this one here. That is number 2. Okay, now we can verify that this carbon here was not counted in the longest chain and this one not counted. We also have Br here. And therefore, how do we then write our name? Our name here will be, we know that it's hex. However, number 4, we have a what? A bromine. So it will be 4. Remember, between a letter and a number, there must be a hyphen or a dash. This will be 4 bromo. Right? And therefore, dash, we had what? We had this carbon and this one. We call them methyls. And they happen twice. So it's 3, comma, 3 between a number and a number. There must be a comma. How many are they? There are 2. So we say di. Di. We say di. We say di. Dimethyl. What is the longest chain now? It is hexane. Hexane. So that's how you name it now. You have 4 bromo hyphen 3, 3 hyphen dimethyl hexane. That's how you answer 2.2.1. Let us move to 2.2.2. We are also asked here to give out the IUPAC name of compound B. Let us go and verify compound B. Compound B, compound B. This is compound B here. Compound B has a triple bond, so we need to count nearest to the functional group. So therefore this will become number 1, this will become number 2, number 3, number 4, and therefore we can look at this. Which one is number 5? We can say you are number 5. Therefore these two here will become the side chains at number 4. So we have 4,4 dimethyl. Let us go and check our name there. How are we going to name this one? We have seen that the longest chain is 5. So longest chain is 5. Longest chain is 5, and 5 is pent, we know that. Alright? And therefore we have seen that we have two side chains at number 4. So we have 4,4. It will be dimethyl. Alright, and we have a triple bond which happened on number 2. So meaning that this pent here will be pent dash 2, and then we put ine or wine here to show that it's what is an alkyne. Let's now combine what we have here. We are going to have 4,4. Between a number and a letter there must be a hyphen. So it is dimethyl. What is our longest chain there? Is pent. So we have pent dash or hyphen 2 hyphen. We have ine there. That's how we are going to name this compound. It's 4,4 hyphen dimethyl pent hyphen 2 hyphen ine. Others they use hyphen. You can also use a dash. You won't be penalized for that. You won't be penalized for that. Let us move to compound C. Compound C, the first thing we should do, we need to check what is compound C. Let's go to compound C. Now this is our compound C here. Compound C, this is compound C. It is an aldehyde. What is the ending there for aldehyde? It's al. How many carbons do we have? It's 1. In fact, we start counting nearest to the functional group. So it's 1, 2, 3, and 4. So we have butanal. So our answer there is going to be butanal. Butanal. So the first thing you must identify, look at the homologous series or the functional group. To be easier for you to then what? To then give us the IUPAC name. So this one is butan, and then the ending is al. So it's butanal. But remember, it won't change. So I think what you can do, you can just write butanal. Butanal. You get 2 marks for that, just to say butanal. All right. Let us move to 2.3. 2.3, compound F reacts with a carboxylic acid to form compound S in the presence of a strong acid. Now we need to identify something here. If we are given compound F, let's check what is compound F. Compound F, we can just double check here. Our compound F is here as we speak. There is compound F. Compound F, it is the alcohol, isn't it? It is the alcohol now. Now, if we add a strong acid, right? If we add a strong acid to that, we can also add the carboxylic acid, which will give us an ester. Our product will be an ester there. So we are doing esterification. But 2.3.1 says write down the type of reaction that takes place. And therefore, what do we have here? We have esterification. So this is esterification. Esterification. This is esterification. In the exam, if you write condensation as well, you get a mark. Condensation. You also get a what? You also get a mark. But it is commonly known as what? As esterification. Now, 2.3.2, we are given a statement first. It says compound S has an empirical formula of C3H6 with an oxygen and a molecular mass of 116 grams per mole. What are we tasked to do here for 3 marks? We are tasked to write down the molecular formula of what? Of the carboxylic what? Acid. So the first thing we need to do here, is to check what we have. We are given the what? Let us look at the molar mass of what? Of C3H6 and then oxygen. What is the molar mass here? We know that carbon is 12, so we can say 12 times 3 plus 6 plus 16. When you punch this in your calculator, you are going to get 58 grams per mole. That is the molecular mass of the empirical formula that was given. Now, look at this. If you say molecular mass of molecular formula, so you can say molecular mass of what? Of the molecular formula, right? Molecular formula, and then you can say over, what do you have here? You have the molecular mass of the empirical formula. So molecular mass of the empirical formula, molecular mass of what? Of the empirical formula. What do you get now if you divide the two? Let us check what you're going to get here. What are you going to get if you divide the two? You are given 116 over 50 what? 58. And if you go to our calculator now and punch the two, which is what? Which is, let's verify it. We have 116 divided by 2. What do we get then? We get 50. In fact, not divided by 2, it's 116 divided by 58. What do we get now? We get 2. So our answer is what there? Our answer is 2. All right. So if our answer is 2, what is compound S now? What is compound S? What is compound S? Compound S will be equal to, remember it was C3H6O, right? If I times by 2, this will become C6H12 and then O what? O2. Now what is remaining now? What is the molecular formula of what's remaining? Remember that our alcohol there had 4 carbons. Now I have 6, meaning that the remaining carbons are going to be 2. So the molecular formula now will be C2H what? H4 and what? And then oxygen there, which is O what? O2. This is the what? The molecular what? Molecular formula. So that's how you get your molecular formula. You can check what you have done. We looked at the molecular mass of the empirical formula. We took the molecular mass of the molecular formula. We divide by the molecular mass of the empirical formula, which was 2. We take our 2, we multiply from our empirical formula. It gives us 6. Now that we have 6, but we know that our alcohol had 4 carbons, meaning that 4 plus 2 will give me 6. If I minus 4 from 6, I will get 2 then. And therefore, this is my answer now. All right, grade 12s, this is how you're supposed to answer question 2.